Alright, so what we're going to be looking at in this lesson is how to solve equations that have variables that are in the exponent. So those are called exponential equations. I have a little phrase that I want you to get in your head that hopefully will remind you what to do here. I love it when my variable is in the exponent because all I have to do is take the log of both sides. So you're going to hear me say that a lot in class. And that's the key to these problems. If your variable is trapped in the exponent, in order to get rid of it, you're going to have to take the log of both sides. So this first problem, I'm actually going to show you 3 different methods that you can use it, because we have different logs that we can use. So different logs are going to have you solve the problem differently. All will result in the same answer. So in number 1, again, the problem is that x is trapped up in the exponent. The only thing that's going to get that down is to do a log. So you could literally do the log log on both sides. The whole idea with using the log is that now, because I use the log, the exponent is allowed to pull out in front. So it'll be x log 5 equals log 134. And then to solve for x, I can divide by the log of 5. And then this part you literally type in your calculator and it will give you the answer. And for this one on your calculator, you don't want to put anything as the base of the log, so you'll skip that and just put the numbers in. You should be able to get 3.043. So that's just the first way on how you can do one of these problems. The second way you could do one of these problems is you could use the natural log. Instead of log log, you could use the natural log. So I do the natural log on both sides. And again, the whole idea with doing the log is what that allows us to do is we can drop down our variable now. So it's going to be x natural log of 5, natural log of 134. You divide, and you type that in your calculator. It will give you the same answer. And it actually is a little bit easier to type on these calculators because you don't have to worry about skipping over the base. And I do suggest that you try typing it on your calculator, maybe pause the video and try it just to make sure you can get the right answer. The last one is my preferred way to do this, but it only works because we have our fancy calculators. If you didn't have a fancy calculator, you couldn't do it this way. You'd have to do it the first or second way. And it only works if you only have one type of base in the problem. So all the bases of the problem are 5, or all the bases of the problem are 7. If there's 2 different bases, you have to use one of the first 2 methods. So what I like to do is I literally like to look at that 5, and I like to think to myself, how am I going to cancel out something that has a base of 5? Well, to cancel out a base of 5, I have to have a log base 5. So I literally will take the log base 5 on both sides. And then what happens with the 5 and the log base 5 is they cancel out. And I just have to type this part right here on my calculator. Your calculator will accept that as something you're allowed to type in. So you would type it in your calculator and you will still get that same answer of 3.043. So this is 3 different methods. You kind of get to pick which one you prefer. Again, I like this last one, but this last one only works when everything's the same base. So let's try some more. So as we look at these next problems, they're going to have a little bit more in them. The first thing you need to do is you need to think about what you're going to do to get to the x. You still need to think unwrap. What do I have to get rid of first? What's farthest away? So looking at something like number 2, we're going to have to subtract the 6 first. The log isn't necessarily going to be your first step. You have to try and isolate the part that has the x attached to it. Then when you get to the step where you're trying to get the x to drop down, this is where you have to take the log. And again, I like to do my cheater method, and I like to say I'm going to take the log base 2 on each side. going to be log base 2 of 2 to the x equal to log base 2 of 9. And then what happens is the log base 2 and the 2 cancel like we had practiced earlier. Earlier when we first started talking about logs before Thanksgiving break. And then you're just going to type in your calculator log base 2 of 9 and it will give you the answer. 3.169, which is going to round up to 70. So then in number 3, the first step is to get rid of the 7, because that's on the outside of the problem, so we would divide by 7 first. We have e to the 2x equals 9. Now what's on the outside of the problem is the e to the 2x, and you have to remember what the inverse of e is. E is called the natural base, its inverse is the natural log. So for e you're going to have to use the natural log, which we write as ln. That's what we're going to insert on each side, so it's going to be the natural log of e to the 2x equal to the natural log of 9. And then again, the natural log and the e cancel out. Those are inverses of each other, so it's just 2x equals the natural log of 9. And your last step is to divide by 2. So when you look in the book, they're going to give you two answers. They're going to give you the answer with the log in it, and then they're going to give you the decimal approximation. You just have to type it in your calculator to get the decimal approximation. In class, we did have a big debate about it's the natural log of 9 first, then divided by 2 on the bottom. It's not the natural log of 9 halves, so you don't want to type that in. So this turns into 1.099. Again, any of these things I'm doing in the calculator, pause and make sure you understand the calculator part of it, that you can type it in and get the right answer. Alright, let's try a few.